Welcome to The Explainer. Today, we're diving straight into a massive medical mystery. We're looking at ketamine. You probably know it best as an anesthetic, right? Well, somehow, it actually manages to reverse severe depression in literally a matter of hours. We're going to pop the hood on the human brain today and see exactly how this anomaly actually works.
So, how exactly does a controversial drug flip depression on its head so fast? To really get why this is such a game changer, we first need to take a hard look at the reality of how we've been treating depression up until now.
Which brings us to the antidepressant waiting game.
For well over 50 years, the medical world has really leaned on the monoamine hypothesis. Basically, the idea that depression is all about a lack of neurotransmitters, your serotonin, your norepinephrine, your dopamine. And our traditional meds target that exact system. But here's the catch. There's a huge time lag. It can take weeks, sometimes even months, just to see if they're doing anything. And even more brutal, up to 46% of patients just don't respond to them at all. That's almost half of the people looking for help stuck with what we call treatment-resistant depression. For them, exhausting every available medication without getting any relief it's completely agonizing.
But then, we see ketamine's rapid impact.
Enter ketamine. It was actually FDA approved way back in 1970 as an anesthetic, but researchers recently stumbled onto this incredible contrast. While the traditional drugs are taking weeks or months to build up in your system, a sub-anesthetic dose of ketamine can start lifting depressive symptoms in as fast as 1 single hour. The effects peak in about 24 hours and can hold for a week or two. It's a completely different paradigm. But how?
It's all about rewiring the brain.
To really wrap our heads around this rapid shift, we kind of have to drop the old chemical imbalance mindset. Instead, we need to talk about neuroplasticity. That's your brain's amazing ability to essentially rewire itself, to adapt, to build new connections. And this is key because major depression is strongly linked to a physical deficit in this exact structural rewiring. Chronic stress literally shrinks certain parts of the brain. It degrades those vital synaptic connections over time. So let's trace the molecular domino effect. Zooming right into the brain at a cellular level, we can actually see the biological chain reaction that ketamine kicks off to fix those broken connections. It's a rapid 3-step reaction. First, a unique glutamate burst. Second, activation of AMPA receptors. And third, initiation of the mTOR pathway. Let's break those down, starting with that initial spark. This glutamate burst is entirely unique to ketamine. You just don't see it with traditional antidepressants. By binding to inhibitory interneurons, ketamine triggers a massive surge of glutamate, which is the brain's main excitatory neurotransmitter, right in the synapse. This surge is literally the spark that turns the engine over on this rapid rewiring process. Once that glutamate starts surging, it hits the receptors. Ketamine essentially acts as a roadblock for NMDA receptors, and because of that, the AMPA receptors go into absolute overdrive. This intense activation triggers an intracellular pathway called mTOR. You can basically think of the mTOR pathway as the brain cell's master builder. It's the foreman calling the shots for new cell growth and building fresh synaptic connections. And that builder needs materials, which brings us to the brain fertilizer, BDNF. All this mTOR master builder activity leads right to the absolute hero molecule of this entire cascade, brain-derived neurotrophic factor, or BDNF for short. You can think of BDNF as straight-up miracle grow for your neurons. It is totally essential for keeping neurons alive, helping them grow, and locking in those new, healthy structural connections in the brain. When depression hits, your BDNF levels plummet. Ketamine forces them right back up. Now, to prove how critical this is, look at what happens when you take the fertilizer away. Researchers found that if they chemically block BDNF or its target receptor TrkB in animal models, ketamine totally loses its rapid antidepressant effects. Nothing happens. The magic just stops. So this proves that releasing this BDNF fertilizer is an absolute requirement for ketamine to work. Specifically, ketamine hits the gas pedal on the cellular production line. It takes a precursor molecule called pro-BDNF and rapidly forces its conversion into mature, ready-to-use BDNF. This sudden flood of mature brain fertilizer quickly restores healthy signaling in critical mood-regulating areas of the brain, like the hippocampus and the prefrontal cortex. But, of course, there are still mysteries to solve. While this molecular domino effect is incredibly elegant, real-world science is rarely perfectly neat, right? We're still untangling a lot of complex variables here. Take sex differences, for example. In some rodent studies, ketamine boosted BDNF mRNA in females, but actually didn't in males. On top of that, phenol rats needed intact gonadal hormones, like estrogen, just to show that heightened sensitivity to the drug. We're also still trying to pin down the exact roles of other molecules, like microRNAs and vascular endothelial growth factor. They seem to be playing really important supporting roles in this grand neuroplasticity play, but we don't have the full picture yet.
We also have to talk about a pretty massive methodological gap. See, when studying mice, researchers can directly sample brain tissue to physically verify this molecular rewiring. But obviously, in human trials, we can't exactly do that. We have to rely on testing blood plasma. The tricky part is that a robust spike of BDNF in human blood doesn't always guarantee a direct correlation with an actual improvement in mood. So translating data from animal brains directly to human blood isn't a perfect one-to-one match just yet.
And then there's the whole frontier of bipolar depression. Ketamine is showing immense promise here, potentially acting a bit like lithium by inhibiting certain enzymes. It's showing incredibly rapid anti-suicidal and antidepressant effects for bipolar patients. But the data on how to safely sustain those benefits long-term without accidentally triggering manic episodes or dissociation is currently super limited. It's an area that still requires a ton of caution.
So I want to leave you with this final thought. We now know for a fact that the brain doesn't have to take months to heal from depression. It already possesses the biological machinery to start rewiring itself in a matter of hours. As researchers keep mapping out these complex molecular dominoes, how will fully unlocking our brain's rapid rewiring capabilities transform the future of mental health treatment permanently? Could we eventually synthesize a new drug that perfectly triggers this exact mTOR and BDNF pathway, but totally skips the dissociative side effects of ketamine? It's an absolutely thrilling frontier. Thanks for joining me for this explainer, and keep questioning how things work.